Hello! Right. I thought the easiest way would be for me to go through the entire test, one question at a time, and just go through how it's done. This seems like the easiest way of doing it rather than spending a whole lesson on it. So here we go. First one is a very simple put it in the calculator question. So we've been given a lovely formula here. We've been told that this is the concentration of hydrogen ions. We're then told that the concentration of hydrogen ions is this thing. Well, you just put it in the formula. So minus log 10 of 0.0003. And then we open up my calculator. So negative log 10 of 0.0003. Close the brackets. 3.52. Okay, next one. The pH is 6.6. Calculate the concentration of hydrogen ions in the milk. Well, that means that 6.6 is equal to negative log base 10, 0. Not that, of, should I call it X? Oh no, let's call it H. Let's call it H. Now, there's several different things you can do here, and because this is a recording, I get to do all of them, and you can pick the one that you like. This is kind of the joy of this. So the thing I like to do, first thing to note, I can't change around this log until that negative's gone. You can't do it. There's no rule that connects anything to having a number or even a negative on the outside of a log. So, you have to move it. So either you can move it to this side, negative 6.6 is equal to log base 10 of H. And now I can undo the log. So 10 to the power of negative 6.6 is equal to H, and that is a calculator job. So 10 to the power of negative 6.6. gives me 2.51 times 10 to the negative 7. 2.51 times 10 to the negative 7. Job done. Option 2, if you don't like that and you're feeling a little bit more HL minded, instead you can bring that negative in here, because there is a log law that says n log a is equal to log a to the power of n. Therefore, if I have a negative on the outside, this thing, if I have that thing sitting over there, well then I can move it up to the top of the h with this log law. And if that doesn't make sense, just come find me in school and ask. Equals log 10 of h to the power of minus 1. I've just copied it out again. So therefore, 10 to the power of 6.6 is equal to h to the power of negative 1. But a negative power, h to the power of minus 1, is equal to 1 over h. So 10 to the power of 6.6 is equal to 1 over h. Therefore, h is equal to 1 over 10 to the power of 6.6, which, if I do it in my calculator, gives me the exact same answer, 2.51 times 10 to the negative 7. Pick your answer, whichever one you like. Right, next question. I've just realised that my calculator doesn't always disappear. There we go. Right, the strength of the acid is measured in its concentration of hydrogen atoms. A lemon has a pH value of 2 and a tomato has a pH value of 4.5. In the last part, we did some rearranging. Have a look at that. See, we rearranged it. We changed the form of it. So we're going to use that in this question. So we already know that H is equal to 10 to the power of the negative pH, whatever that is. And we know that because we did it in the last question. We rearranged it with the same steps. So because I know this is true, And I would like to know how many times stronger is the lemon compared to the acid in the tomato. I'm going to do the lemon one divided by the tomato one. So 10 to the power of -2, because a lemon has a pH of 2. Read the question. And a tomato has a pH of 4.5, so 10 to the power of -4.5. And now I just get my calculator and I get my calculator to do it. 10 to the power of -2, whoops, divided by 10 to the power of -4.5. Whoops, not 45, 4.5. 316. Done. Next up, SOHCAHTOA. If you're not sure why I've just randomly shouted out SOHCAHTOA, this is a trigonometry thing. So you've got your opposite, adjacent, and hypotenuse sides. We've got the hypotenuse, and what we're being asked to do is find the area of this triangle. Well, I know that the area of a triangle is half of the base times by the height. The base would be that bit, and the height would be that bit. Well, the purple bit is the opposite side, and therefore I need sine. So sine theta times by the radius. The bottom bit is the adjacent, so I need ca, or cosine. So r times by cosine of theta. I now just put both of these things into the area of a triangle formula. So half the base, so r cos theta, multiplied by r sine theta, which is the height. Now we're going to make it look a little bit nicer, not by much. We're just going to put those two r's together to r squared. Sine theta, cos theta. Ta-da! For anyone that's playing Having Bingo, I'm interested to see how far you get with this one. Right. Use this model. So let's read the full question. RTFQ. The company expects to sell 40 cars in January of 2025. The cars will sold each month can be modeled by a geometric sequence. So immediately, before I do anything else, I'm going to write down what my formula sheet says. My formula sheet says that UN for a geometric sequence is U1 times by R to the power of n minus 1. And Sn is equal to U1, 1 minus R to the power of n, all divided by 1 minus R. Magic. That's another one for Habingo. Anyway, we've got R is equal to 1.1. A must be equal to 40, because remember, sorry, not A, U1, the very first term, must be 40, because that's the one in January. So let's just use both of them. I've been asked to find how many cars should be sold in December. Easy. That's U12, because December is the 12th month. I probably didn't need to say that. Anyway, multiplied by 1.1 to the power of 12 minus 1. That, let's get the calculator out. Good. 40 times 1.1 to the power of 12 minus 1 gives me 114.12. But we're going to leave it as 114. Okay. Hopefully all of that makes sense. Now, we would like to know this total number of cars. Total number of cars. That will be sold in the year 2025. Well, we've also got a formula for that. the sum of the first 12 months is going to be, let's just remind everyone of the equation of the formula, and I'm even going to bring them a little bit further down so that you can see which equation is next to which question that I need it for. There we go. So U1, which was 40, multiplied by 1 minus 1.1 to the power of 12, all divided by 1 minus 1.1. That will be equal to, return of trusty calculator, 40 multiplied by 1 subtract 1.1 to the power of 12, all divided by 1 minus 1.1 is 855. Now, I don't know if I'm going to need this number in another question, but I think I probably will. So I'm going to store this as B. And actually, I regret not storing this one, so I'm going to press equals on this and store this one as A. By the way, I did that by just pressing up. I don't know if your calculators do that or not. Probably. Oh no, of course they do, because you've got the whole thing. Cool, doesn't matter. Right. So, next up, I would like to now know the total number of cars sold only in the year 2026. Now, when I was doing this, I came up with two different ways of doing this. So, again, pick the one that makes sense to you. Method 1, because I can add things up all in a row, if I do the sum of the first 24 months, and then take away the sum of the first 12 months, that only leaves me with 2026. If you think about it on a timeline or a diagram, if I've got 2024 there, oh, not even 2024 there, sorry, 2025, 2026, and then the end of 2026, if I want to add up all of these in one go, well then I could do the whole thing, take away that bit, which will only leave me with the 2026 bit. Again, let's think about this. So the whole way across, all of that is the sum of the first 24 months. That bit is only the sum of the first 12 months. So if I only want this 2026 bit, I can do the sum of 24 months, take away the sum of the first 12 months. Right, so let's do that in the calculator. So we've got the 40 multiplied by 1 minus 1.1 to the power of 24, all divided by 1 minus 1.1. And take away, see, I knew I was going to use it, the sum of 12, but I've done that in the last question, this one. So I'm just going to put that down there as 855. Now let's do that on my trusty calculator. 40 multiplied by 1 minus 1.1 to the power of 24 divided by 1 minus 1.1, and if you remember from like 3 minutes ago, I saved that number as B. There you go. So 2,680. There we go. Job done. Method 2, if you don't like that one. Method 2. Well, instead of doing the 24 months take away the 12 months, you could figure out how much, was it a car? Yeah. You could figure out how much a car is going to cost in 2026, or the January 2026, which is the 13th month from January 2025. Think about it, it makes sense. If it doesn't make sense, think about it for longer. Right. So if I would like to know the 13th one, That's 40 multiplied by 1.1 to the power of 13 minus 1, which my wonderful calculator, if it will please work, there we go, it's going to be equal to 40 times by 1.1 to the power of 13 minus 1. 125.5. And because I would like to use this as a value, I'm going to save it as C. Okay. Now I can do the sum of the next 12 months using this one, this 125, as the first value. So 125.5 multiplied by 1 minus 1.1 to the power of 12, all divided by 1 minus 1.1, is equal to, let's see what calculator says, C multiplied by 1 minus 1.1 to the power of 12 divided by 1 minus 1.1. Same number. Look at that. Just have a look. That number. That number. That number. That number. It's the same number. Therefore, we got it right. I'm trying to anticipate what questions people are going to be asking. And I think people are going to be asking, why is this 13? Honestly, all I can think is just like count it outright. So January, February, March, April, May, June, July. I had to think there. August, September, October, November, December, and then January again. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if that doesn't prove it to you, I don't know what will. Any other questions? I don't know. Ask me in lesson if there's any other questions. Next one, range questions. So, you've been given this as the domain. We would like to figure out what is the range of f. So we put it in the calculator. And we do 2 minus 12 over x, so let's go with negative 7, plus 5. And we'll find I get 8. Interesting. Okay, so f of negative 7 equals 8. And let's do the other one. F of 7, the other end, the top end of my domain, that's the word I'm looking for, is the same thing, but with a positive 7. I get 1. Whoa. I saw a lot of people put them between each other, but actually you don't know the shape of it. So what you need is you need your calculator to tell you what's the shape of this graph. So 12 divided by x plus 5. I'm anticipating someone's going to ask, is there a way I can do this without my calculator, please? And my answer to you is yes, if you can imagine the graph without your calculator. So I guess the question is, can you do this without a graph? No. Well, I guess you could, but you'd have to be very, very clever to be able to imagine this without using the graph. I don't even know how you would. Doesn't matter, I'm getting distracted. So, over at 8, this is, come here, okay. Over at minus 7, there we go. You'll notice that's in this corner, all the way over here. Can I go upwards? Yeah, I can go upwards. That'll bring me to 8. Just have a look at this graph here. That. I'll just have a look at my screen. I'm not sure that's very easy for you to see. Sorry. Give me a second. Hopefully that's better. So specifically what I want you to look at is these bottom numbers here. that I've put in -7 and I've got 8, and this is where it is on my graph. So if I know that it's the right side, this side of -7, it actually goes up. That blue line is going upwards. So my range, f of x, must be greater or equal to 8. It's a very weird one to wrap your head around why that is the case. But looking at the graph, I think, is the best way to explain it. So then on the other side, it's got to be bigger or equal to 8. But way, way over on the other side where x is equal to 7. Let's find that. X is 7. We'll get close enough. Y is 1. And so because I'm on the left side of this now, this side, the left side, my graph is going down. So on this side, f of x is less than or equal to 1. So this is my range. My range, to be completely clear, is f of x must be bigger or equal to 8, but f of x must be smaller or equal to 1. For anyone that's saying that's not possible, it doesn't have to be both at the same time. What I'm saying is any number bigger than 8 is allowed, and any number smaller than 1 is allowed. So I guess what I'm saying is it's not allowed to have any number between that. Because if you look at the graph, again, there are no blue bits between there and there. At least between +7 and -7. This is all just blank space, nothing there. Okay, hopefully that makes sense. If not, come find me. Okay, find an expression for the inverse function, f minus 1. The domain is not required. Yay. F of x is equal to 2 minus 12 over x at 5. Don't quite trust my memory. Minus 12 x plus 5. Yep. So the trick here is to make this an x, to make the original x a y, and now we're going to rearrange it. So I'm going to move this all the way over there, and this over there. So 12 over y add 5 is equal to 2 take away x. A little bit more rearranging. I'm going to put that up there and that down there. By that I mean I'm going to multiply by y plus 5, but divide by 2 minus x. So that gives me 12 over 2 minus x is equal to y add 5. Then the last thing is I'm going to take away that 5. So 12 over 2 minus x minus 5 is equal to y. So therefore f minus 1 of x, the inverse, is equal to 12 divided by 2 minus x, all minus 5. Done. Find an expression for the inverse function. Well, we did that. Oh, I wrote it in the wrong box. Whoops. There we go. Write down the range of f minus 1 of x. Now you might be sitting there looking at the inverse thinking, oh my lord, what's the inverse of this? But this is where you have to remember how functions work. If I have f of x, it takes the numbers, let's say 1, 2 and 3, to 4, 5 and 6. So if my domain is 1, 2, 3, my range becomes 4, 5 and 6. But then if I have the inverse function, the one that goes backwards, it goes the other way along this, well then that means that the domain is the range of the before one. Try and wrap your head around that one. So f of x had a domain of between -7 and 7, and a range of what we've written before. I'll write it down, but you don't need it for this bit. Not needed, not needed, not needed. Anyone that asks me why this is needed, you are wrong. It is not needed. I'm saying, I don't know how many times I can say that. Let's just like put it in really big bold. Not needed. I bet someone will ask me why that's needed. Anyway, therefore the range of f of x minus 1 is that. It's the domain of the before one. So the range of the inverse of x is minus 7, well, between negative 7 and positive 7. Done! Yay. Super. That shouldn't be an x in between there. That should be an f minus 1 of x. 7. Right, next up. Sorry if I'm going too quickly, but the best thing about this is you can rewind it and watch it again. And you can even put me in slow motion. Right, so the function f of x is equal to the ln, or the natural log, of this. Find the inverse. Okay, so we leave that as x. We change any already existing x's into y's. And now we rearrange this thing. So remember that this is log base e, the natural log. So I would like to undo this log, so I get e to the power of x is equal to 1 over y minus 2. Now we're going to divide by e to the x and multiply by y minus 2. So y minus 2 is equal to 1 over e to the x. Therefore, y is equal to 1 over e to the x, add 2. Ta-da! Therefore, f minus 1 of x is equal to e to the negative x plus 2. These two are the same thing. Solve this. Yay. Right, e to the minus x plus 2. Oops, sorry, wrong way around. Natural log of 1 over x minus 2 is equal to e to the negative x plus 2. Now, this is not possible to solve with algebra. Cannot use algebra. Cannot use algebra. The reason that I know that is because this is an e to the power of an x, and this is an x inside a logarithm. Feel free to try it and try and get the two x's in the same place. And if you find a way of getting those two x's in the same place, please tell me, because we can sell that to mathematicians for a lot of money. So, if I can't use algebra, what do I do? Well, you use your calculator. Y equals, and you're going to plot. You're going to write out each one. I'm currently, there you go, natural log's down there. So let's clear this. Natural log of 1 over x minus 2. Oops. And the other one, e to the power of, oh, e is there. Wait, okay, careful if you're using this calculator. This is the letter E, not the number E. Be careful. I might be wrong on that, actually. Someone might want to correct me. But that to me looks like the letter E. This is the E we want to use. So negative x, add 2. Okay. Now graph the both of them and you'll see that they cross over in this little bit here. I can go for a zoom box. By the way, if I'm doing things too quickly on the calculator, just go backwards and watch what I've done to find out how to do it. Whoops. That one. Enter. Let's go down a bit and across a bit. There we go. So I would like to find that intersection point, because at that intersection point, they are equal to each other. And I can do that with calc. You see this blue bit? So I press second, calc, and I would like the intersect. Now, first curve is the blue one. Second curve is the red one. Guess. I don't know why it asks you to guess. There we go, job done. So x is 2.12 and y is also 2.12. So let's write that down. X equals 2.12. If you doubt it, put it in the calculator. Whoops, let's hide that one. There we go. Ln of 2.12, so 1 over 2.12. Oh, minus 2 is equal to 2.12. And e to the power of, oh, e's down there, oh, e's over there, of negative 2.12, add 2, is also equal to 2.12. I hope this satisfactorily proves it to you. Next up, this was basically a graphing question. Determine the maximum voltage of the two sources. Use your calculator. We're allowed to use our calculators, so let's just do that. There is some very complicated maths that we could do to find the maximum, but let's not bother. Let's just use our calculators. So if I would like to know the max of the two combined sources, well then that means I would like to know the max of 30 sine t add 60 sine t add 10. That is exactly what I shall put into my calculator. Let's move that window along a little bit. There we go. So y is equal to, I can see a mistake with my calculator now, and I'm going to leave it there because it's going to create a problem in a second, and then I can actually show you what happens when it goes wrong. And if you're sat there thinking what's gone wrong, have a quick look, maybe pause the video. Can you spot what's wrong with my calculator before I press equals? Right, enter, graph it. Whoa, it's gone nuts. Okay, I heard how British I was with that one. I hear it now. There we go, it's all going a little bit mental, which to be fair, it should go mental, but not quite that mental. Now the problem was, it's in radians. Well done if you spotted that. So let's change this with mode to degrees, and graph it again. Much better. See, this is now nice. We like this. The maximum is the top bit, the highest bit. Anyway, so calc again, maximum, so I press 4, and left bound it, left bound, right bound it, right bound, don't know why I asked for a guess. There we go, maximum is 82.5. And just to cover myself, I'm going to write done with calculator. Okay. Next up, using your graphic display calculator, find a suitable equation for the combined voltages. Now this one I found quite fun. So we know from our calculator, and you can still see it, that it's got this curvy shape that goes like that. Now usually a sine graph looks like that. So my suggestion with these is write out what it should be and then figure out how they've changed it and use the rules of transforming graphs to help you figure out where each number should go. And we're going to do one number at a time. So V0 should be the maximum height. That bit's going to be V0. How do I know that? That's a very good question. Because on a normal sine graph, the highest bit is 1. So at most, sine can be 1. So that means that this V0 times by 1, when sine is at its absolute maximum, will be this top number. So V0 is the 82.5 that we found a second ago. Okay, now let's deal with A. A deals with how spread out the graph is. I'm going to leave that one just for a moment because I'm going to trust or hope that everything's the same. And if it's not, I'm wrong. Okay, B determines how much left or right it goes. So the x value, you can still see it on your screen actually. The x value is 63.835. So 63.835, and it's supposed to be at 90. This spot here, this red dot is the same. Whoops. This red dot is the same as this red dot. It's at the same point of the graph, so they should be in the same place. So if it was at 90, that means that it's been shifted that way by, I can't do this in my head, 835. Calculator. Let's hide the other calculator. There we go. 90, take away 63.835. So 26.165. 26.165 is how much it shifted. And it shifted in the negative direction, which means that B should be positive. At 26, let's write this in black because it's an answer, 26.165. I don't know of the best way of convincing you that that's true. The only thing I can think to do is I'm just going to graph it with the numbers that I've used. So 82.5 multiplied by sine x, so x is t in this case, add 26.165. Ta-da! The red line, okay, if you don't know why I'm saying ta-da, that's because the red line is exactly on top of the blue line. There's a little bit of a difference, and that's probably me rounding things wrong, or rounding things more than I maybe should. But they're exactly on top of each other, for the most part. That means that I got it right. This is why I didn't do anything with A earlier. It's better to just try it on the calculator and figure out if it's in the same place than go over the very, very long and difficult work of trying to figure out what A is going to be otherwise. So, A isn't there, so it's going to be just 1. And it's an answer, so I should really write that in black. Job done. So V is equal to 82.5 sine t add 26.165. Next up, okay, this is just testing, do you remember graph transformations? Well, if I do f of x plus 3, this goes up by 3, so the y-intercept becomes 8 plus 3, 11. The y-intercept of the graph 4x. The only thing I can, so remember when we did this in class, and if you don't remember doing this in class, go back over the notes, I guess. We did this on Desmos, we played around with it, and we discovered that this x thing stretches it left and right, horizontal, parallel to the x-axis. But if I'm stretching a piece that is already on the y-axis, it doesn't go anywhere, because x is 0. I think that's maybe the best way of explaining it. The second way of maybe explaining this is noting that, well, f of 0 is equal to 8. So f of 4 times by 0 is still f of 0, so it's still 8. It hasn't moved anywhere. And find the x-intercept of the graph, f equals 2x. Well, it stretches it. I should have maybe noted, it stretches it to the inverse of this coefficient. So if this is 4, it would stretch it by a factor of 1/4. This is 2, so it stretches it by a factor of 1/2. I will at some point make an entire video just about this. So if it doesn't make sense, come find me and I'll explain it properly to you. Anyway, because that scale factor is 1/2, I do 5 multiplied by 1/2 gives me 2.5. So my x-intercept becomes 2.50. And I've realised I haven't written any of these as proper fractions. Not fractions, wowzer. Proper coordinates. There we go. Describe the transformation f of x plus 1. Now the key word here is describe. That means words. What is it actually doing? Well, to use the technical words, it's a translation. Left by 1. Or if you want to be super fancy, you can say translation parallel to the x-axis by -1. Or you can say a shift to the left parallel to x by -1. This is also acceptable. I don't know why, but the word move is not acceptable in the mark scheme. I think that's because basically all of the transformations cause some kind of movement. So it doesn't really narrow it down. That's my idea anyway. Okay, question 8. I enjoy doing this one. Right, so we've got AB, sorry, start again. We've got a triangle ABC. AB is 85 metres. AC is 110 metres, and the angle between the two is 55. Whoa. Well, let's draw that. If it's tricky, draw a picky. A, B, C. That's 85, that's 110, and that's 55. And I would like to know the area. Well, the area is equal to half AB sine C. This is a formula given to you on your formula book. So half times 85 multiplied by 110 of sine 55 is my answer. So I'm going to use my calculator for this. I feel like I'm going to use this one just to show you how these buttons work, although I'm pretty sure you've by this point figured out how to type in these things. And if you haven't, why? Okay, there we go. So 3,829, so let's round that to 3,830. Job done. Because this is only part A, I'm a naturally paranoid person when it comes to maths. So I'm going to save this number as A. We'll just keep it there in case I need it. Right. The second one, 6 marker, big question. The farmer would like to divide the field into 2 equal parts by constructing a straight fence from A to point D. He would like the field to be in 2 equal parts. I already read that bit, but this really is the key to the entire question, so I'm going to say it again. So find the length BD. Now read that very carefully, because if you don't read that question, you can spend a very long time finding the wrong thing. So that's 55 degrees. There's going to be a fence drawn in there. That point is D. So we've got A, B, C. And I would like to find this length here that I shall call X. Now remember, that's 85. That's 110. So how am I going to do this? Well, if I know that it's half of the area, exactly half of the area, then I now know that the area that I'm looking for half of the total area is, using my calculator, half, not 1/5, 1/2, multiplied by A. 1914. So let's round that. Actually, let's not round that. Let's store that as B, and only in my answer, whoops, store that as B, and only in my answer am I going to call that 1914. 1949. Okay. How are we going to work it out? All this stuff. Anyway, I'm going to use the sine rule and the cosine rule. This is why it's a six marker. It is a problem-solving question. You've got to figure it out. So if I know the length, here's the plan. I'm going to find the length BC, and then using the cosine rule, I'm going to figure out that angle there. And once I know that angle, I can find the area of this triangle, and I already know that the area of this triangle is going to be 1914 meters squared. And that's going to let me figure out what x is. And if you're sat there thinking, how on earth did you think about that? That's a very good question. I think I've just done a lot of these questions. This is why practice questions are so important. You've just got to do a lot of them. I've just realised my calculator's been covering up all of that. I'm going to do that again. Whoops. Let's start that bit again. Let's just grab all that. Am I going to re-record it? No. Why? Because it's late. And I might re-record it and stitch it in. But let's face it, I probably won't. Right, let's draw that again. So we've got A, B, and C. We've got our fence to D. Remember, this is an angle of 55 degrees. The whole thing, not just a bit of it. That's 85 meters. That bit's 110 meters. And we would like to figure out the length BD. So let's call that X. The plan, as I said, although you couldn't see it at the time, is to find the length BC, that bit, use the sine rule with this bit and this bit to figure out that angle there. And once I have that angle there, I shall figure out the area of this triangle. But I know the area of the triangle, that's not going to disappear, whatever, as 1914, so I can use that to figure out what x is. So let's do that. So the first thing in my plan is to figure out what on earth is BC. Well, BC, I'm going to use the cosine rule that you can grab from your formula sheet. So a squared equals b squared plus c squared minus 2bc cos a. So BC is equal to the square root of AB squared plus AC squared minus 2 times by AB times by AC times by cos of 55. Let's write that a bit better. There we go. And I would like the square root of all of that. So that is the square root of 85 squared plus 110 squared minus 2 times 85 multiplied by 110 multiplied by cos 55. And it's just occurred to me that I'm very interested to see if the subtitles can keep up with me as well. Right. Calculator time. Calculator. Hello, calculator. Square root of 85 squared plus 110 squared minus 2 times 85 multiplied by 110 multiplied by cos 55. Check that it's in degrees. Yes, it's in degrees. Enter 92.73. And if you are realizing how paranoid I am, you know that I'm going to save this as... Do you know what? Let's go with A. Let's save this as A. There we go. Saved as A. So I've got the whole number. No rounding until the end. No rounding until the end. Okay. Now, sine rule. Sine rule, I'm now trying to work out. So let's just recap. I've got now this bit, B to D. I know that this length, because of what I've just worked out, is 92.73 meters. I can now use the sine rule. Let's put that down there. I really need to learn to remember to put that calculator away. There we go. So we've got this length here, B to C, 92.73. So we're going to use the sine rule, being sine A over A is equal to sine B over B is equal to sine C over C. Let's use that. So, I'm still going to call this theta, this little squiggle. So, sine 55 divided by 92.73 is equal to sine theta, the unknown thing that I would like to find, divided by 110. That therefore is the same as 110 sine 55 divided by 92.73. It's equal to sine theta. So theta is equal to inverse sine 110 sine 55 divided by 92.73. Now time for the calculator. Will I remember to put the calculator away at the end of this? Sine minus 1, fraction 110 multiplied by sine 55. Check that we're in degrees. Yes. Divided by A. Yes, I could use the answer button. I'm not going to. To be honest, I'm not going to, just out of stubbornness at this point. Store that as B. Whoops. Or do that. Store that as B. There we go. 76.33. Actually, technically that's 3.4, isn't it? Okay. Put the calculator away. So now we know that this angle here, theta, is 76.34 degrees. Now, we're on the home stretch here, we're on the last bit, so I'm going to grab this and shrink this down a little bit. There we go. Not too much. So now the area, which remember was saved on my calculator, and now I've got a dreadful feeling that I've accidentally overridden it. I have actually overridden it, so I'm going to have to find that again now. Whoops. Half. You're probably thinking, is this bit necessary? I've lost enough marks on maths tests because of this to be paranoid enough that I don't want to lose a mark because of this again. I'm sure it's maybe unnecessary. Am I going to do it anyway? Yes. Just because I've gambled on this one and not done this in the past, and every single time I've managed to lose marks. There we go. Alright, now let's store that as D. Okay. So, area equals 1914 is equal to half 85 multiplied by x multiplied by sine 76.34. There we go. Let's put all that into the calculator in one go. So, half. I need to remember where I saved 76, because that was B. That was as B. Half multiplied by 85 multiplied by x. We don't know x yet. Sorry, I'm getting tired. I'm doing this in the wrong order. First thing we're going to do, we're going to rearrange all this. Let's put the calculator away, we don't need it for now. So 1914 divided by a half times by 85 times by sine 76.34 will give me x, because I've rearranged it. Therefore, x is equal to, now it's time for the calculator, so let's just remember, d was that one, b was that one, so d divided by a half, and this is where I wouldn't have been able to use the answer button because there's two things that I need to put in, not just one. Half multiplied by 85 multiplied by sine of b. Go. 46.36, round it to three significant figures, 46.4. Job done. Wow, this is becoming a long video. Well done if you're still awake. Woo! Finance time. Nice and simple, this one. So, option 1. Repay the mortgage over 20 years at an annual interest rate of 5%, compounded annually. This is an important thing. In fact, let's just highlight the bits that are important. It's over 20 years, that's important because that's the time period. The interest rate is 5% and it's compounded annually. Those are the three important bits. She's taking out a mortgage of that much. Let's move on. Option 2, $1,000 every month, that's important. Annual interest rate of 6%, that's important. Compounded annually, that's important. Right, calculate the monthly repayment using option 1. Calculator time, apps, finance, TMV solver. Well, it's 20 years with monthly repayments, so 20 multiplied by 12. I is equal to 5%, present value is the whole thing. Payment, let's leave that as 0. Future value is 0. Payment per year is 12 because I'm making monthly repayments. Key word in there, monthly. That means 12 of them. And 1 compound per year. Now, payment, I'm going to put alpha solve, $784 every month. Let's round out to three significant figures, so $785. 785. Next up, calculate the total amount. Sophie, before I forget, actually, you should really leave all of this in there. And now I'm being quite lazy and I'm just copying and pasting out the calculator. You need to actually write it all down. Unlucky. Calculate the total amount Sophie would pay using option 1. Okay, well, I've got that much multiplied by 240. That much. So, rounding it to three significant figures, that is 188,000. So, 240 multiplied by 785 is equal to $1,188,000. Calculate the number of months it will take to repay the mortgage using option 2. Okay, well, calculator time. Let's have a look at this. Whoops. It's so same present value, different interest rate. Interest rate is 6%. The present value is the same. The payment is exactly 1,000. Now, because I'm paying it, that has to be negative because it's leaving me. Does that make sense? I think that makes sense. Okay, anyway. Future value is 0. Whoop-de-doo. Payments per year, 12 again. It's monthly repayments. And compounds per year is 1. Done. The only thing that I would like to know is the number of repayments, which is the months. So n alpha. Solve 180. So let's take that there. That's annoying. It's covering up that number. I'm going to do that again. There we go. Get rid of that one. Get rid of that one. 180 months. Next question. Calculate the total amount Sophie would pay. Okay, well, this one's very, very easy. It's 100 and... Ooh, actually, no. Sorry, 181 months. There you go. 181 months. I have to round up to the whole number of months. Anyway, so 181 multiplied by $1,000 each month gives me $181,000. Give a reason why Sophie might choose option 1. Okay, well, let's have a look. In option 1, I was paying less each month. Pay less each month. Option 2, I pay less overall by about $7,000. Pay less overall. There's a whole bunch of things that you can say for this. It's not just those two. You could say option 2 gets paid off faster. That would be a very reasonable thing to say. You could say... No, to be honest, those are the two main ones. I'm sure there's lots of other things you can think of, but they're the two that I think of the quickest. That one pays less each month. This is less overall. But also for option 2, it's quicker to pay off. Maybe that's a good thing. Sophie decides to choose option 1. At the end of 10 years, the interest rate is changed to 7%, compounded annually. Use your answer to calculate the amount remaining on her mortgage after the first 10 years. Okay, well, it's going to be the same stuff as before, but right at the start. So instead of 240, it's 10 years times by 12 months. The interest rate is 5%, just to remind you of the first option, 5% interest rate. Present value is this much. Payment, I don't quite trust it. I'm going to work it out again, I think, actually. Present value is this. So there we go, that much. So this is how much I pay every month, $785. So if I change this now to 120 months and I ask it to recalculate what the final value will be, I get this number. So my final value after 10 years is $74,353. Hence, calculate the monthly repayment for the final 10 years. Okay, well, that means that the final payment or final value becomes the starting value, 74,353.4386. I'm paranoid. I will write in all the numbers. Future value is going to be 0. I've got 120 months left to pay it off, so that's 10 years of 12 months. And I would now like to know what my payment each month is. Something has gone wrong. I found what went wrong. I didn't change the percentage. RTFQ, read the full question. This is now 7%. So let's make that 7. And let's change that to, that's as it was. Good. Payment I would like to work out. Solve $855. Do I need to round that? No. Job done. Right, question 16. The observant amongst you will notice that the whole question or the whole page has jumped. That's because Clever Clogs here forgot to press record. I decided to pause it between the two questions and I forgot to press record again at the start. Or actually, I sort of moved the page a little bit and then pressed record, so sorry. Anyway, right. The Texas Star is a Ferris wheel in blah 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 blah, has a diameter of this, blah 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 blah. The lowest point is 2.7 meters above the ground. Following diagram, blah 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 blah, makes 1.5 revolutions a minute. Okay. And we've got a cos function. So as soon as a question suggests a function that it wants you to use, the first thing I want to do is to draw out what is that function anyway. What does it look like? What are its key points? Now, I'll be honest, these are things that I just sort of remember. I just keep these in my memory because I've done this for too long. You, however, are more than welcome to just use the calculator. Now, as well as forgetting to press record, I seem to have just closed the calculator app entirely. So give me a moment while that loads up again. There we go. Is it capturing big camera? No. Give it just a second, sorry. Magic. Ta-da! Let's move that to the side so it doesn't go over my drawing. Right. This is a spoiler for later. I did the whole question before. Right, here we go. So, y is equal to, spoilers, negative, wrong negative. This calculator needs this negative. Cos x, ta-da, draw it. And where's the draw button? There you go, graph, window. Because this is trigonometry that we're dealing with, we're going to put it between negative 10. I put in the wrong kind of negative. Negative 10, 360. And we'll have y going between negative 1. Actually, let's make it negative 2 and positive 2. And if you're wondering how I know what those numbers should go between, I already know what cos should go between. So I know that that bit should be 0. I know that that should be 360. You can't see what I'm writing because the calculator's in the way. I know that this should be 0. This should be 360. I know that this highest point should be 180. Those are the bits I need to know. So A is going to be the distance from the middle to the top. The middle to the top. This bit. That's A right there. So on our one, well, the distance from there to there is going to be half of the diameter, which is 30.9. So 61.8 divided by 2 gives me 30.9, because that is going to be the distance from the middle bit to the top. I could almost draw my cosine graph over the top, where this is going to be the middle and that's going to be my distance A. Oops. B. Well, B is a little bit more tricky to work out. B is going to be how much do I need to stretch it to make it fit the new graph. Now, in a previous question, I told you to leave this one until you have more information. Well, I do have more information on this question. It's this bit, 1.5 revolutions per minute. So on my sine graph, cos graph, sorry, if this is the start and this is the end, I need to work out what that's going to be this as well. Take notice that time is in seconds, so I also need this bit B to be in seconds. So I know it's 1.5 revolutions in 60 seconds, that's 1 minute. So I want to know 1 revolution is in how many seconds? Well, that's dividing by 1.5. This is also dividing by 1.5. So this is now 40 seconds. So on my Ferris wheel, this is also 0, and this is 40. So I've gone by some multiplier, 360 multiplied by something gives me 40. Pretty easy to work out. Let's give that a letter. Let's call that K. I like the letter K. K is equal to 40 divided by 360, which is the same as 1 divided by 9. Magic. So 360, wrong way around, sorry. 40 divided by 360 gives me 1/9. But if you remember from our lessons of transformations, this is the inverse multiplier. So this creates a stretch of 1/b. So if I have a stretch of, my stretch is 1/9, that means that B must be 9. So B is equal to 9. D's going to be, let's have another look at the cosine graph. So usually cosine goes from -1 to 0 to 1, and everything is exactly around 0. My Ferris wheel is not around 0. My Ferris wheel is around some other point. This is the middle point of all the up and down motion. So I would like to know for this question, how high up is that point? Pretty easy to do. I already know that that bit, this bit from here to here is 30.9. I know that that's 2.7, so 30.9 added to 2.7 gives me 33.6. Ta-da! A ride on a Ferris wheel lasts for 12 minutes in total. Calculate the number of revolutions. Well, okay, well it does every minute. It does 1.5 revolutions. So in 12 minutes, it's going to do 18 revolutions. If you don't believe me, just do it on your calculator. 1.5 multiplied by 12 gives me 18. Okay, suggest for exactly one ride, suggest an appropriate domain of h of t. Well, for one ride, we are told one ride is 12 minutes. So my time is going to go between 0 and whatever 12 minutes of 60 seconds is. 720 seconds. Suggest an appropriate range for h. Well, remembering back to when we did domain and range, the domain was the x part and the range was the y part. So the y part on our one goes between 2.7 and the highest point on my wheel. the highest point being right at the top, which is very easy to work out. That's going to be 61.8 added to 2.7. So 61.8 added to 2.7. I don't know why, but I really don't trust my mental maths with that one right now. 61.8 added to 2.7, 54, 64.5. So this is the maximum height, and the minimum height is 2.7. So that's my range, and that shouldn't be a t in there, that should be h of t in there. Okay, getting near to the end now. So we've got a cowboy who, well, cowboy statue, who has a height of 16.7 meters. There we go, 16.7 meters. And I would like to know how long, well, sorry, let's just read the question. I would like to know the length of time for which a chair is higher than the cowboy statue. Well, what I'm going to do is I'm going to graph both of them. So we've got this thing, the cosine graph, which represents the height of the chair, and then we've got 16.7, which represents the height of the cowboy. And I would like to know the first time that the chair goes above it and when the chair goes below it. And I'm going to find the difference between those two times. How do we do that? Very simple, calculator. Now, parts A and B, sorry, just A, asked us to figure out all the parts of this equation. So, h of t is equal to negative 30.9 cos 9t add 33.6. And that's putting together all the pieces, A, B, and D, from the first three parts. A is 30.9, B is 9, and D is 33.6. So let's put all of that together. That's my function. I've got another line, y is equal to 16.7. That's the height of the cowboy. And I'm going to put both of these into my calculator. So y is going to be equal to negative 30.9 multiplied by cos 9 times by t, add 33.6, and another one of 16.7. Draw it. If you're wondering why nothing came up, have a think about where we set our window, and it's way out of it. So anyway, so x minimum, let's still keep that as negative 10. X maximum, well, we know that it takes 40 seconds for each revolution now, so let's make that 50. Scale of 1, y minimum, well, I'm going to be looking up at around 16, so let's make the minimum 10 and the maximum 20. And then I reckon that's going to put me, there we go, exactly where I want to be. And I would like to find the intersection of those two graphs. So second, calc, intersect. First curve, let's just follow it through. Oh, there you go, nearly missed it. That blue one is my first curve, that red one is my second curve. I don't know why it asked me to guess, it's very strange. Anyway, so intersection is 6.315, so let's make that 6.32. T1 is equal to 6.32. T2, again, we can use our calculators for this. So the next intersection point, second, calc, intersect, and now we just have to choose points on the graph closer to the second intersection. So I'm going to keep on scrolling along. Click, 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 click. I want to hold it down actually, make time go a bit quicker. There you go. So click on the blue one, click on the red one. 33.68. There we go. And the difference between these two is going to be equal to... Oh no. Oh, well, big calculator's covering up little calculator. Okay. 33.68 minus 6.32 gives me 27.36 seconds. There you go. The IB wants us to round to 3 significant figures at all times, so 27.4 seconds. End of. Right, let's go through the last bit nice and quickly. The maximum height is 65.2. We've got A, B, and D in there. Identify which parameter will change. So the maximum height is now going to be 65.2. So that's going to move my whole wiggly line upwards. So that means D's the bit that's going to change. To find the new value of the parameter, well, remember, D was the distance from the bottom to the middle of my wheel. If I now know that I've got a maximum height of 65.2 meters, well then, to find that bit, I just need to divide it by 2. 65.2 divided by 2. Do you know what? I really wish I had the ability to do this in my head. Divided by 2. 32.6. There you go. Job done. I hope this all makes sense. If it doesn't, come and find me and ask me for help. If I went too quickly, set the playback to be slower. And if that doesn't work, again, just come find me for help. Cool. Okay. Have a lovely day. Bye.